Hello, and welcome to 5 Minute Math. My name is Aaron Daffern, and today we are looking at the 8th grade STAAR mathematics test. You can follow along with a personalized item analysis report using either the QR code on the screen or the tiny URL that you see as well. You can jump to any item if you use the bookmarks at the bottom of the video or these timestamps that you see on the screen. For number one, we are looking at volume. This is standard 8.7a, and we've got an image here of a marble. Kind of looks like a basketball, but either way, it's a sphere, and it's got a diameter of 13 millimeters, and we need to find the measurement closest to the volume. All right, so in this particular case, we don't have to memorize the formula for volume. Let's look at our reference material, and we've got volume, and let's look for the volume of a sphere. You see it at the bottom there. V equals, let me go ahead and write that down for us. V equals 4/3 pi r cubed. All right, so that's going to be our formula that we're using. And really, there's only one number that we're sticking in here, and that's the radius. Now, here's the thing. They don't give us the radius. Typically, they're not going to give you the radius. They're going to make you think about it a little bit. They give you the diameter. So the diameter is all the way across, right? So the radius is from the center point to one of the edges. And so the radius is always half the diameter. So if the radius is half the diameter, that means we're going to take half of 13. So the radius is going to equal 6.5. So what we're going to do is we're going to input this into our calculator. It's going to be 4/3 pi, and then it's going to be 6.5 cubed, not 6.5 times 3, 6.5 times 6.5 times 6.5. That's 6.5 times itself 3 times. All right, so let's get our calculator open. Let's bring it over here. And we've got our formula right there that we're going to use. And we can use either calculator. Let's use the graph calculator for this one. Decimals also works as well. All right, so we're going to do 4/3. So 4 divided by 3. And then we're going to multiply that by pi. So that means we have to hit our second to get the blue and that caret symbol to get our pi. And then we're going to get our 6.5. That is our radius. And then we need to cube it, right? So we're going to use that caret to get to the power. And you see we get the exponent button. And then there we go, 4/3 pi 6.5 cubed. And it's going to be 1150.346. And so 1150 is going to get us our closest. And there we go. Our answer there is A. Now let's see how we did across the state of Texas on this particular problem. And as you could probably guess, seeing as how simple, one simple calculation, we had to use the calculator, we did pretty well. We had 72% of our students get this correct, and that is fantastic. Our threshold for feeling comfortable about a problem is 60%. When we get above that, we're feeling pretty good. We had 13% of our students choose B, and that's just students forgot to use the 4/3. They just multiplied pi r cubed. Not sure why you'd multiply that, all of that, and forget the 4/3, but that's how you could get that. And then when we get down here, 7% and 8%, that's just statistical noise, just a lot of guessing down there. So overall, a pretty easy one to start with. In fact, this is the fourth easiest item on the test. So really, the one challenge here is they're typically going to give you the diameter. You need to convert that into a radius. And once you can do that, you are good to go. For number two, we are ordering numbers. This is 8.2D. And once again, we're going to need our calculator for this because we're trying to find the list that shows the order from greatest to least. And I've got three terms. Let's make them all decimals. And I've already got a 4.84 that is a decimal. All right, so I've got two other terms I need to turn into decimals. 39/8 and then square root of 24. So let's get our calculator on this one. All right, so let's just do 39/8. That means 39 divided by 8. So that's 4.875. So let's do 4.875 for these 39 over 8. And then we will do the square root of 24. All right, so we're going to hit the square root button. So we're going to hit the second, the blue second, hit that x squared button to get that blue squared, square root, and then 24. All right, so 4.8989, so on and so forth. So we're going to 3 digits here. We're going to the thousandths place for the 4.875, so let's do that here. 4.8989. Let's make that 9, second 9, round up, so 4.899. Let's do that, 4.899. And then once we have the 4.899, we can put this away because we don't need it anymore. 4.899. All right, greatest to least. All right, so this 4.875 goes down to 484, but then it goes back up, so that's not going to work. All right, so 4.899 then goes to 4.875, then goes down to 4.84. Okay, so this looks good. You notice how this goes up and this goes down, so that doesn't work. And this is actually least to greatest. This goes up all the way. All right, so our answer there is B. And so let's select that. And let's see how we did across the state. This also seemed to be a fairly easy item for students, 73%. So we are feeling pretty good about that one. And yeah, I thought this was going to be our second most chosen answer. 13% chose D, and that's the putting the numbers in the correct order. They just chose least to greatest rather than greatest to least. So there were definitely some students that did all that work, and they just didn't identify this. So that's a little bit of work we need to do with them. We had 9%, right, choose C, and then 5%. So anything less than that 10% is really statistical noise. So this is even easier than the first one. This was tied for our second easiest item on the test. So we're definitely starting this test off with two pretty easy items, which means they're just going to get harder as the test progresses. For number 3, we are looking at standard 8.5G, identifying functions. And we've got 4 different graphs here. And we are looking at some discrete data here. So we've got dots. We don't have continuous lines. And we're looking for the graph of these discrete data that does not represent y as a function of x. So we spend quite a bit of time in 8th grade talking about a function, what makes a function, so we need this definition here. It's unfortunately not a part of our reference materials. If we don't know what a function is, then we're just basically guessing here. So a function is a relation or a relationship between input and output values. So most of the time, we're going to look at x and y values. So input and output. Now, there's one key thing between this relation between the input and the output values, where each input, here's our key, leads to exactly one output. All right, so once again, if we're thinking of input and output, right, for our purposes, our inputs are our x values, right? Those are our independent variables. Our outputs are our y values, our dependent variables. So each x leads to exactly one y. So a lot of times what we'll use is we'll use a vertical line test if we have graphs. Can you draw a vertical line through each value? And if you get two values, look at this right here. I drew a vertical line on x equals 1 and I hit two values, which means this is not a function. If you can draw a vertical line, that means it is a function if it only hits one value, because each x should only have one y. So even though this is a straight line on C, each x only has one y, so we're good. This is a straight line down, slanting down, each x has only one y, this is good. This is a parabola, this is from a quadratic function that we'll spend more time with in Algebra 1, but even though it's curved, each x only has one y, which means it's good. So our answer here is A, and it's because of this, and I'll circle it again right there in blue. Right there, when that x equals 1, we've got two coordinate pairs. We've got 1, comma 2, and then we've got 1, comma 0. And when you have two x's, or two y values coming out of the same x, then it's not a function. So that is our correct answer. Now, this one was a little bit more challenging. And so we had 49% of our students get that one correct. How do we do on the other ones? Well, we had 8%. That was pretty easy. We had 19% choose C. So for some students, that horizontal line messed us up. And they thought, well, if y equals 2, that can't be a function. Well, y equals 2 can be a function. And then this one was the one that really tripped us up. This is a parabola. Now, 8th graders might not have been exposed to a quadratic function. And so this is a function in which you're going to have, once we get a continuous line, you're going to get an exponent, right? This might be x minus 2 or something like that, or x minus 3. And so you're going to get that x, and then it's going to be squared. So this is just an example of what that's going to be. We'll look at that more in Algebra 1, but now those are still functions because each x has only one y value. So, suggestion here, as this is the 19th most difficult item on the test, would be for teachers to expose them to all kinds of graphs, even absolute value graphs, even graphs of, exponential functions, graphs of quadratic functions, anything, because it doesn't matter the shape of the graph. It matters, does each x have only one y? And if so, it is a function. And that is the key that we're looking at when we're thinking about identifying functions. Next, for number 4, we are looking at trend lines. This is 8.5D, right? 8.5D. And we've got this graph here, and we've got a scatter plot. We need to find a prediction. Now, I'm going to scroll this down because our line is going to be very important, and I don't want to have to scroll up and down. So we are looking for prediction for 90. Okay, so we're looking for that x value of a 90-page report and which of these times work. Now, there's a few different ways that we can solve this because a lot of times what ends up happening is we kind of go off the graph a little bit. And so let's think of if we just want to graphically solve this, right? So this is going to be, we can assume this is going to be proportional because 0 time to read is for 0 pages. Right, and what we're doing is we're looking for a line of best fit. And what we're wanting to do is we're wanting to draw a line. So I'm going to actually uh, have no grid. So I'm going to use this connect line feature. So what I'm going to do is I'm going to add some points right there. I'm going to add some points as to where I think we've got some good space in between. So you see these two right here. I want to kind of pick a spot right in between those two. Okay, so maybe right there. And then these two, this point right here actually looks pretty good. And then you see I've got these two right here. I'm going to pick a spot right in between those. What we're doing is we are just trying to pick some spots in there and then put a spot right there. Now it's not going to be perfect, but what I want to do is I want to see if I can find a line that connects all of these. And I'm going to get as close as I can. I'm going to go off the graph. All right, so that kind of connects most of those for the most part. All right, so that's a pretty good line. Now you notice my 90 is we're off. Okay, so we're off the graph. So that's not going to be super helpful, but I can eliminate some, right? So it's going to be maybe, if we say this is 110, right? This is maybe, the next one will be 120, right? So maybe 120, 130, right? So maybe this 125. All right, so it's off the graph, so we're going to need to do a little bit more work. Let's do this. Let's use the add point features, and let's add these y values, okay? So 95 and 90 is going to hit right there. Okay, that's not going to work. 105 is going to hit right there. Okay, that's not going to work. They're both too small. So I've got the 125 and then 155, and those are way off. This might be that 125. It's kind of hard to hit that because that's coming off. But the 155 is going to be way up here. So I'm thinking that's going to be off. So the best way for us to probably really do this is to let's find 2 points that look like they're pretty good estimates, and let's actually calculate our slope. Okay, so our line of best fit, this was a pretty good point right here, right there. That was kind of between this one and this one. And so that was, let's call that an x value of 38, and the y value is right on that line of 50. And then let's find another point. And this one was pretty good. And that was 50, let's call that 54. And it's a hair above 70, let's call that 72. All right, so if I've got that, all right, we can use our reference material. Let's see if we've got a slope of a line. There we go. Change in y over change in x. M equals y2 minus y1 over x2 minus x1. Let's do that. We're going to use those 2 points there. M equals, let's make this our y1 and our x1. Let's make this our y2 and our x2. So m equals y sub 2 minus y sub 1, x sub 2, x sub 1. So that's going to be 50 minus 72 over 38 over 54. Now, they're both going to be negative, which is going to end up canceling each other out and making a positive, which is fine. We want a positive slope. So this is going to be m equals negative 22 over negative 16, which two negatives make positive. So it looks like my slope is 11/8. Now, how does that help me if I figure out what the slope is? Well, let's see if we have that here. Direct variation. Look at that. This is a proportional graph, right? We're starting at the origin, which means we have direct variation. Y equals k over x, or y equals kx, excuse me. So we can say y equals kx direct variation. Well, this k is representing my slope. So I can say y equals 11/8, and then the x they wanted us to use is 90. All right, so I can bring out my calculator here, and I can multiply that 11/8 by 90, and look what I get, 123.75, and that gets us really close to that 125. So that is going to be our best way. There's a few different ways to solve that. Once you get off the graph, it is good to kind of calculate it. So that is our answer of C. Now, that was a lot of work that we did. So as you can probably tell, this one's going to be a little bit more difficult for our students. And in fact, it definitely was. So we had 31% of our students, 31, you heard that correct, get that correct. We actually had more students choose B, 42%, and we actually had a lot of students choose A. Now remember, no, not really anyone chose D. Remember these two here, and let me put them back on. Remember, these were the two that we immediately discounted, because once we drew our line of best fit, this 90 and the 105 was right there, and then the 90 and the 95 was right there. And our line of best fit was way beyond that. It went way up here, something like that, kind of off the grid. So that line of best fit, even though it went off the grid, we ended up having to do some calculations, would have been helpful to eliminate the two answers that kind of distracted our students. And so even though that line of best fit wasn't enough to actually estimate the correct answer, we needed to calculate it. That's a great starting point because this was our seventh most difficult item on the test, or at least tied for the seventh most difficult item. So this is one in which, for the most part, when you see a scatter plot like this and you're doing a trend line in eighth grade, it's going to go off the graph. So we are going to need to calculate and estimate slope in order to get a more accurate answer. So next, for number 5, we are modeling slope-intercept form. This is 8.5i. And as you can see here, we've got a drag and drop 2-point problem. Right, 1 point for each correct answer. So we have a table, and we need to create an equation in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So really, we're looking for the m and the b. So the m is our slope, and remember that slope is going to be the change in y sub 2 minus y sub 1 over the change in x. So for this to work, pick any x value, any y value. As long as the x and the y are paired, it doesn't really matter. So I'm going to make this my x sub 1, and this is going to be my y sub 1, and I'm going to make this my x sub 2 and my y sub 2. I'm going to pick the extremes. You could have picked those two middles. You're going to get the same slope because it's a straight line. That's how slopes work. Just make sure you copy them down correct. So my y sub 2 is negative 1 minus my y sub 1 is 11. My x sub 2, negative 4, minus my x sub 1, 12. So minus 1 minus 11 is going to be negative 12 over, I've got a negative 16. Now, those are two negatives, so they're going to make a positive, and that's going to simplify to 3/4. All right, so that is my slope, 3/4. And you notice I've got 3/4, negative 3/4, 4/3, so a lot of different choices there. So I can substitute that in. I can say y equals 3/4 x plus b. I want to substitute in a y and an x, and I'll just use 2/8 to actually find that b. So I'm going to substitute in an 8 and an 8. So let's do 8 equals 3/4 times 8 plus b. I could do that with 4 and 5. I could do that with any of these pairs. And if you're not sure about it, I would suggest substituting all 4 of these pairs. You'll get the same thing. That's how this works. So I can simplify that 8 and that 4, right? That's just going to be a 2 left over. So 8 equals 3 times 2 plus b, right? And so that's going to be 8 equals 6 plus b. To isolate that b, let's subtract 6 from both sides. b equals 2. All right, so there we go. I've got my 3/4 x plus 2 is my correct answer. Now, this was a 2-point problem. So to get full credit, you needed both of those correct. And we had 41% of our students actually get that correct. Both items, we had 20% get one correct. We don't know which one they got correct, which one they got incorrect. We don't get data on the individual answer selections. So how we calculate the percent correct on this one is we take full credit on the 2 points, half credit on that, so 41 plus 10, because that's half 20, and we're looking at 51% correct. So not quite at that 60% threshold. We still had 39% of our students get that incorrect. So this was on the harder side, but kind of towards the middle. This is the 20th hardest item on the test. This is pretty basic. Students should have lots of practice with tables of values, finding the slope-intercept form. That is a major work of what we do in 8th grade. For number 6, this is 8.3a, similar proportionality, and this is a challenge because take a look at what we have here. We've got two different items. They are similar and they are not oriented. You can tell two different ways. First, okay, you've got that little symbol right there and this little symbol right there. They're not oriented the same way. And then you can also look at the letters, right? P goes with K. Okay, so P goes with K, and you notice they're not in the same position. Same with that. Q goes with L, R goes with M, T goes with N. They give the order of the letters in the same way. We need to rotate one of these, because if not, it's going to be extremely difficult. And so let's go ahead and shift this down here so we can see all of our answer selections. And let's rotate. I'm going to rotate this little tiny one, and I'm going to bring it over here. Okay, so what I want to do is I want to kind of draw a shape that kind of looks exactly like that big one. And I'm going to try my hardest to get it to kind of look like that. But what I want to do is I want to make sure I get my values exactly correct. Okay, so this one is R. Now, if I go clockwise, right, so I'm going to use a counterclockwise, excuse me, a counterclockwise direction, then I'm going to go this way, and I'm going to go to T, which means this is from R to T, 4.12. So just pick a direction. I'm going counterclockwise. Counterclockwise, I'm going to go P, and so T to P is 3. Counterclockwise, I'm going from X. That's the one I need. That P to Q is X. And then from Q to R, to kind of finish this counterclockwise, 4.28. All right, so that would be my suggestion, is to redraw one of them. I also could have redrawn this big one and rotated it, but now I can visually match up which sides go with which. Okay, so let's look at these proportions. So we've got x over 9. Okay, so here's my x, and then here's my 9. Well, I can already tell you that's not going to work. Just period. Because the x can go with any of the other sides on its own shape, right? As long as the next half of the proportion follows the same corresponding sides. Or the x can only go with this 8.91 because those are the two sides that are similar. But the x and the 9 have nothing to do with each other, and the rotation really helps me see that. Now, you notice how this x on the original and the 9 are both on the left side. So that's where it's getting kids messed up. So let's look at the 8, x, and the 8.91. Okay, so x and 8.91, that looks good so far. Okay, which means I need a proportion of a smaller side to a larger side. So I've got the 4.12. All right, so this 4.12 matches the x, which means it needs to go to that y right there. But you see how that 4.12 goes to the 9. The 4.12 matches with that y. So that's not going to work. But this first part was good. It was the second part that didn't work. So y, we're starting with the bigger one, goes to 4.28. And once again, it's not going to work. That y does not go with that 4.28. Y goes with 4.12. So we can already mark that one off. So it's got to be D. So y goes with 4.12. Yes, we're going from big to small. So then 9, another big, goes to the matching 3, small. Yes. So D is our correct answer. So the key here was to get it rotated, and to just realize you have to go big to small, small to big, or you can stay within the shape, but then the other pair has to match as well. So this one was difficult. Take a look at our answer selections. 30% gets it correct. 24% chose A. 23% chose B. 22% chose C. So I'm guessing there's about 5% to 7% of our students that actually got this right. The rest of this is just pure guessing, and we had about 20% of our students guessed it correctly. But this, when you see answer distribution like this just lets you know this was extremely difficult, and it's the rotation. So when we practice this, teachers, first, keep the orientation the same so we understand how proportions work on similar shapes. But to get to that star level of rigor, you've got to rotate one of the objects and let them figure out the best way to keep track of the proportion by rotating one of the other objects. This was difficult. In fact, this was the sixth hardest item on the test, and it is that rotation that makes it extremely hard. And for number 7, we are growing money over time. This is 8.12C, personal financial literacy. We've got a table of values here talking about Shakira's investments. So Shakira is investing $200 each year, right? So we've got this plus 200, plus 200, and then what we have is the ending balance. So we've got 2% interest, so that 2% on $200 is going to get you $4. So you add the $4 into your 200, you get 204. Then you take this 204 that you already had, you put in another 200. So now you've got 404 earning interest. So 2% of 404 is going to get you 808. You add that 808 to the 404, get 412.08. Right? So if we were to continue this, we're going to add another 200. 200 plus that 412.08, right? We would get 2% off that 612.08, and then we would get a new ending balance, so on and so forth. So she's going to continue to deposit $200 each year. She's going to continue to earn 2% each year. So how can we best describe each ending balance? Well, let's take a look at our options. We're not actually needing to calculate. We're simply needing to describe what's going on. That's why I spent so much time describing what's actually happening there. The balance increased by 2% of the sum of 200 and 204 every year. Well, no, that's what happened the first year, right? 2% of that 200 and 204. That's what happened right here. But then that next year, it's going to be the sum of 200 and then whatever your previous ending balance is, because that ending balance is changing every year. The balance increases by 2% of 200 every year. Now, that would just get you an extra $4 per year, but that's not taking into account that you're carrying over your ending balance. She's not withdrawing any money, so that's not going to happen. 2% of each prior year's ending balance. Well, that would only get you this, but remember, she's also depositing an extra $200 per year. So what's happening is it's increasing by 2% of two things: the sum of the prior year's ending balance and that extra $200 each year. Now, that seems like a very wordy but straightforward problem, but unfortunately, this was extremely difficult. We had 28% of our students get this correct. And look at the answer distribution. We had 20% on A, 27% on B, 25%, which means they really didn't have much of a clue as to what's happening on this. So if I were a teacher working with this, I would definitely work on, before we even get into this, give them this setup, right? And have them calculate the next few years of money, right? So we never finish this. This 200 plus the 412.08 equals, then times that by 2%, right? You're going to get 1224. And then you need to add the 1224 to the that 612.08, right? That's 612.08 plus the 1224, and you're going to get 624.32. This is how you get kids to really understand what's going on. Make them calculate year 4 and year 5. If they can do that, then they're ready to answer the questions. But just going straight into answering the questions is going to cause them to get confused because there's a lot happening here. This, in fact, was the tied for the fourth most difficult item on the test. Because if you look at our answer distribution, this is indicative of a whole lot of guessing. There's a large portion of the students that got it correct that probably just guessed it correct. They didn't necessarily know what was going on because that is a pretty poor showing on 8.12C. Next, for number 8, we are looking at surface area, 8.7b. So let's look at 8.7b here. and we've got a triangular prism, and we are looking for the total, not the lateral, total surface area. So let's see. Do we have anything in our reference material that will help us with total surface area? And you see right there, and I'll put that right towards the bottom so we can find it here. Surface area is split up into two categories, total and lateral. So we're going to look at total, and this is a prism. So we're going to look at prism. So for total, for prism, it's going to be right there in the bottom right. S equals pH plus 2B. Now, if I don't know what that means as a student, that's not really going to help me. So there's still a little bit of work that needs to be done here. This P is the perimeter of the base. So we need to know exactly what that means, not the perimeter of the whole shape, the perimeter of the base. And even before we do that, we need to identify the base. This is a triangular prism, right? So we're going to identify these two triangles right here as my two bases. And the three rectangles that are connecting those two, right? That's what's stretching it out. That's like the lateral surface area. All right, so what is the perimeter of my base? Well, each base is a triangle, and that is 10, that's 12, and that is unknown, but it's picked up as a 10 in the back. So 10, 10, and 12 gets me 32. Now, what is my height? If I were to stand this up, my height is the distance between the two bases. And so what's connecting these two bases? It's that 18. So even though it seems like pretty straightforward with our formula here, still a lot of things we need to know in order to figure this out. And then I've got to double the B. What's the B? Well, the big B here is the area of the base. So there's still quite a bit of work we have to do there because my base is a triangle. And so what's the formula for the area of a triangle? It's here in case we need it. So let's go ahead and open it up. Area of a triangle is the 1/2, put that up at the top there, 1/2 base times height. Now, it's a different base. It's little b. 1/2 base times height. So since we're just looking at this triangle right here, the base is our bottom, 12, and then my height is 8. Right there. We're not looking at the slant height. So that's it. I can honestly just plug all of that into my calculator if I need to, because that is everything that I need. So let's do this. We're going to do 32 times 18, right? That's the perimeter times the height. We went ahead and just mentally calculated that perimeter of the base, the 10, 10, and 12. The height is 18. Then we're going to add 2 times, and then we've got our area of a triangle. 0.5 times 12 times 8. And there we go. We're going to get 672, and that is our answer B right there, 672. A lot of calculation there, but if we can set up the equation, we can let the calculator do the work for us. So let's see how we did. Across the state of Texas, we had 40% of our students get this correct. So that was tricky. We had 22% choose A. Now, what happens with A, that means we're leaving off the rectangular faces and we're just calculating the area of these two triangles. Now, C is 21%. So C gets really close. What you end up doing is you just you leave off that 1/2 when you're calculating the triangular base. So you end up overshooting your answer. And then D is 16%. That's the lateral surface area. That's just these three triangles, right? So that's a little bit harder to get to on purpose there. So 14th hardest. This is one in which we just need a lot of practice, and probably the biggest challenge for students here is this part right here. We give them the formula pH plus 2B. But this P is the perimeter of the base. The height is the height between the bases. The B is the area of the base. I mean, there's a lot of work that needs to happen there. So this needs a lot of practice, even interpreting the formula before applying it. Because once you interpret it, plugging the numbers into the calculator is not that difficult. The challenge is trying to figure out what each of these letters is referring to. For number 9, we are writing equations and inequalities. This is 8.8a. And we have this verbal description here. The tank starts off containing 1,060 gallons of water. All right, so I'm going to just draw kind of a tank. Let's just make it look like a cylinder. All right, so there's my tank. And it starts off containing, and let's do this, 1,060 gallons of water, and 35 gallons of water leaks from the tank every hour. So I'm just going to draw this little leak right up here, and we'll say 35 gallons per hour. Of course, if it's leaking from up top, eventually the water level will go below that. So the leak might have to be down from there, but that's fine. You get the idea. So we're subtracting 35 gallons an hour. At the same time, an empty pool. All right, so we're going to get this big in-ground swimming pool here, and is filling up with water at a rate of 480 gallons per hour. So this is water is being poured into it, plus 480 gallons per hour. So which inequality represents all the possible values for x, the number of hours, right? So this hour is the one constant between those two that have passed when the tank contains less water than the pool. Okay, so what do we know about the tank? So the number of hours that have passed when the tank, here's the tank, it's this one right here. So what is the tank? The tank is starting out with 1,060. That's just a flat number. And it's losing 35 gallons per hour. And we're going to use X for hour. So 35X. And we've got this pool over here, and it's gaining 480 gallons per hour. So 480X. And we want the number of hours that have passed when the tank contains less. So here's my tank. We want that to be less than the pool. So here we go. And we are looking at our answer here of C. So if we can take the words and put them straight into an inequality, we should be good to go. We did fairly well on this one. So remember, our threshold is 60%. We got 61% of our students to get that correct. So we should feel pretty good about that. Now, our second most chosen answer was 23%. Kind of stands out. And you notice we did all of the work correct. The difference there is in the inequality symbol. So that's a little bit frustrating when you can set up everything else correctly and you just kind of mess the inequality symbol. And it literally is right there, less. We had 8%, 9% for A and D, not really standing out there much. This was pretty easy. In fact, this was the 11th easiest. So good job for our students for at least getting above that 60% threshold on writing equations and inequalities. For number 10, we are representing dilations here. You see we have a drag and drop, so this is a 2-point problem here. This is standard 8.3c. So we have a small triangle, and it's dilated with the origin at the center of dilation, and it's creating a large triangle, P prime, Q prime, R prime. So we need to create a rule. So let's match up the coordinates for each of these right here. So P is 1, 3, okay? And it is going to go to, and I'm going to write it underneath it here, right? P prime is, let's see, that's 3, 9. And let's do the same thing for Q. So Q is 3, 1. So just kind of reverse there. And then Q prime is 9, 3. Okay, so once again, I just kind of reverse the x and the y coordinates. And then I've got r and r prime. So I'll do those over here. R is 1, 1. And then r prime is 3, 3. Okay, so we're dilating it, which means we're multiplying it by something. If it was a congruent shape and it was just being translated, then we could add something. But in this case, we're multiplying by something, and I think honestly the easiest way to see that is my relationship right there between r and r prime. What do we need to multiply each of these original values by to get our prime values? Well, the only way to get from 1 to 3 is to multiply by 3. So let's see if that works for each of these. So P, 1 times 3 gives me 3, and 3 times 3 gets me 9. And then 3 times 3 gives me 9. So there we go. That multiply by 3 is going to work. So what I want to do is I want to say I'm going to take my original x, y, then I'm going to take each of them, multiply them by 3, and that's what I'm going to get. So I need my 3x, 3y. Now notice you have to put those in order. If for some reason you decided to put the 3y there and the 3x there, that's incorrect. So the order does matter. I need my 3x first, my 3y second. This was a 2-point problem. So we had 44% of our students get this correct, both points. We had 18% get 1 point. So if you take half of that 18, you're looking at about 53%. So it didn't quite hit that 60% threshold. We had 37% of our students just not get any points, and we're not 100% sure which answers they chose as opposed to the ones that they were, looking for. So 53%, this made this the 18th easiest, or tied for the 18th easiest item on the test. So not quite that 60% threshold, but definitely on the easier side of the test, especially if you ended up looking at the R. The 1, 1 to 3, 3 was pretty much right in your face there as regard to what that scale factor dilation was. For number 11, we are looking at slope as a unit rate. This is 8.4b. And we've got these graphs that we've got to look at here. We've got a printing store that uses 24 ounces of ink in 18 minutes. So I'm going to write it like this, because this is the way they give it to me. 24 ounces, 18 minute. I might not necessarily need it in that ratio, but that's the order they gave it to me, so I'm going to go ahead and record them. So we're looking for a slope that represents the average number of ounces used per minute. So that's what I need. Ounces per minute. Ounces per minute. And take a look at this. My ounces is my y, and my minute is my x, and that's what my slope is, right? The change in y equals, or the change in y over the change in x equals my slope. So if I wanted to take a look at that, that's, what did I say that was? 24 over 18. All right, so that's 1.33333, or we can say 4 over 3, right? That's what that's going to simplify down to, 4/3. So I'm looking for one of these that what I could do is I can just look at my origin, right? And my change in y means I'm going to go up 4 over 3. So I should land right there at y of 4, x of 3. And a does not do that for me. 4, 3. B does that for me. Let's look see if any of the others do that before I continue it, because it needs to not just be the first one correct, obviously. 4, 3, O. C is very close, but it's not quite there. And then D is not right. So let's make sure that B continues. So up 4 over 3 is going to get me to 8, 6. Going to get me to 12, 9. Okay, yes, that's what that is. That 4 over 3 is my slope as that unit rate. And this is kind of tricky for our students. We had 43% get B, which is the correct answer. Get that correct. Let's get that back on there. 43% got that correct. A was 13%, so not many students chose that, but C and D were kind of tricky for us because look how close C is. 23%, and obviously we're very, very close. This was a 6/4 or a 3/2 unit rate, so that's close to a 4/3. And then D was 22%, and so that was not really that close, but it kind of messed up some of our students. So this ended up being very difficult. This was the 15th hardest item on the test. And so before we even look at the graph, right, we needed to find the ounces per minute. So we needed to convert this 24/18 into a 4/3. So we need to have that 4/3 firm before we even started trying to recognize what it looked like on a graph. If we jump straight to the graph, that's probably going to throw us off. For number 12, we are describing the volume of a cylinder. So you notice here that we are not even fully calculating. We are simply looking for a formula or an equation that can be used to find something. This is standard 8.6a. So we have a cylindrical swimming pool. All right, so I'm going to draw my swimming pool here. We're going to just make it look like an above ground pool here. It has a radius of 9 feet. All right, so let's do this radius of 9 feet and a height of 4 feet. All right, so I didn't do it proportionally, but that's fine. 4 feet. Which equation can we use to find V, the volume of the swimming pool, in cubic feet? Well, it is a cylindrical swimming pool, which means I need the volume of a cylinder. What is my volume of a cylinder? Look at my reference material there. Volume of a cylinder is V equals base times height. Okay, that's only part of it. So V equals base, big B, times height. Let's get that big B. Now, what is the base? The base is a circle. So I need to find this big B here means the area of a circle, area of the base. So what is the area of my circle? Well, it's that pi r squared. So instead of just that B, I'm going to say pi r squared is what that B represents. And then I still need that height afterwards. So volume is going to be pi r squared times the height. Now let's plug some of these numbers in. Since that base is pi r squared, I can say my radius is 9. So volume equals pi times 9 squared. And then my height was, they gave it to me as 4 right there. So let's see which one looks close to that. And you see I've got it right there at C. So C is our correct answer. We don't actually need to calculate it. We just needed to set it up. And so we had 53% of our students get this one correct. So not horrible. Not 60%, but not horrible. We had 19% of our students choose B here. So we're just omitting the pi, right? It's the exact same except for it didn't include that pi. We had 17% of our students choose D. And what this is the circumference. So we know pi was involved somehow, but we just chose the wrong formula. And then we've got 11% getting close to statistical noise for A. So this was tied for our 18th easiest item on the test, closer to that 60% threshold, and we're almost getting there. We just need a little bit more practice. For number 13, we are looking at proportional and non-proportional graphs. This is 8.5F, and it's pretty straightforward here. We've got a representation. 2 of them are graphs. 2 of them are actually equations that we need to find that describes a proportional relationship. Now, we don't necessarily have that word proportional showing up in our reference materials, but direct variation, y equals kx, The difference between that and what's right up above it, slope-intercept form, is that slope-intercept form has a plus b. That means that that line is offset from going through the origin. Either it's pushed up or it's pushed down, and the y-intercept is something other than 0. Direct variation is proportional, y equals kx, which means it goes straight through the origin. And so when we've got this a, you see this minus 6 right here. This follows our slope-intercept form. That minus 6 means that line is going to be pushed down a little bit like this. It's going to kind of be like right there at minus 6. It's going to be like that. B, look at that, right there through our origin. So that is going to be our correct answer. This plus 4, that's going to have a slope of 1, but it's going to be pushed up 4. So it's going to go like this. And then if we look at D here, it's just a vertical line, right? This is just x equals negative 4, right? And so it doesn't go through the origin at all. All right, so that is a pretty straightforward problem here. Our answer is B, and quite honestly, most of our students found it to be pretty straightforward as well. We had a good percentage of students getting this correct, 73%. So that should make us feel pretty good. We had 10% on A, we had 10% on C, and we only had 7% on D. So getting pretty close to what I would consider statistical noise. This is actually tied for our second easiest item on the test. So not much really to think about here. We should be lucky if we should get more problems as pretty simple as this. Next, for number 14, we are looking at lines and angles. This is standard 8.8D. And what we have here is the beginnings of what will continue on later in high school in geometry. We're looking at parallel lines cut by transversal. So here are my parallel lines right here. And then what happens is transversal, right? That's a straight line that cuts both of those parallel lines. And what we're supposed to figure out is what happens to the angles when the parallel lines is cut by another line diagonally, a transversal. Before we do that, let's move this down here a little bit. We'll have to kind of see what we're doing and then shift it down. So look at those parallel lines. You notice how when I cut this, these are what we call alternate interior lines, right? So these, the two interior angles inside that parallel line that are on alternate sides of the transversal are equal, right? So that 45 and 45. Notice I've got a 68 and I've got a 68. So alternate interior angles are congruent. I've got a 48 and I've got a 48. Okay? Now, another thing that we're supposed to notice is that when you've got these this transversal, right, it ends up creating two supplementary angles. Okay, so these two are supplementary, which means they equal 180. So if I get this angle up here, that means it's the same as this angle down here, and that means the other angle on the other side of that line is supplementary. It adds up to 180. 68 and that 112 make 180, 48 and that 32 make 180. And then finally, if we make a right angle out of it, what I'm going to end up getting here is, you notice that, and I'll do this in green here, you notice that this transversal ends up making complementary angles with this straight line. So this is complementary angle, which means they equal 90 degrees, 45 and 45, right? I've got 68 and 22. I've got 48 and 42. They all equal 90 if you draw another straight line. So knowing all of that, let's come down here. Let's take a look at what we're supposed to be doing. With here, we're supposed to be filling in x, y, and z. All right, so let's clear this off here, and then we can use that bottom one here. So we're supposed to figure out what x, y, and z are. Okay, well, remember, first, we found that all of these were complementary. That means if this is 90 degrees, that right here is 90 degrees. Well, if that's already 30, then I could say z plus 30 equals 90. Subtract 30 from both sides. What do you get? Z equals 60. All right, so I'm going to put a 60 right there in my z. Let's do that. Now, if this was 60, remember the 48, I think we did that in red, the 48 always equal that 48. So z equals y because they're alternate interior angles. So if z equals 60, then y equals 60. So we can put that 60 down there in y as well. And then that last one we found was the supplementary angles right here. Right? These two were supplementary. That means they equaled 180. So that means y plus x equals 180. And if y equals 60, 60 plus x equals 180. Let's subtract 60 from both sides. That's going to get x equals 120. All right, so there we go. That is my full credit 2-point answer there. 120, 60, and 60. This ended up being the 10th hardest item on the test. Now, we don't have numbers on which of these answer selections were chosen for any of these. All we have are percentages for 2 points, 1 points, and 0 points. If you wanted 2 points, you needed to get all 3 correct. We only had 24% of our students get all 3 correct. So that's 3 correct. 1 point means you get 2 out of 3 correct. And we only had 17% of our students get that. So if you take half of that, you're sitting at about 9%. You're looking at 33% correct. You had 59% not get any of this correct. So this was extremely difficult. A lot of inferencing, but everything that they gave us was actually in these top 3 examples. In 8th grade, they have to give you the 3 worked examples. And so we need to use those 3 worked examples to be able to derive some understandings about alternate interior angles, complementary angles, and supplementary angles as well. So for number 15, we are looking at slope and y-intercept. This is 8.4c. And we've got a table of values here. An artist is starting with some paint and bottles. And then we've got some additional. So started with some paint means we have this y-intercept. Okay, that's the real world kind of usage of a y-intercept. Something it's not directly proportional, doesn't go through the origin of 0, 0. They're starting with some, and then they're buying the same number, right? So there's my unit rate or slope right there, buying that same number each week. And we have a linear relationship, so it's going to be a straight line, right? So how many bottles did the artist have at the start? Well, since we're looking at a linear relationship, right? And we know we're going to start with some. I'm going to use my slope-intercept form. Y equals mx plus b. I want to get into that. First, let's figure out the slope. And if we need to, the slope of a line is that m equals, and then change in y over change in x. Right, so I can say m equals y sub 2 minus y sub 1, x sub 2 minus x sub 1. So we can pick any values. Let's pick easy values to work with. So let's just make that our x sub 1, our x sub 2, y sub 1, y sub 2. Any 2 pairs work as long as you match them up, the y with the x. Okay, so my y sub 2 is 34. My y sub 1 is 25. And then my x sub 2 is 7. My x sub 1 is 4. So really what I get is 9 over 3, which means 3. All right, so she's buying, if it's a woman, she's buying 3 bottles a week, which makes sense. You want that to be a whole number. You probably wouldn't buy a decimal number of paint bottles per week. So m equals 3. All right, so y equals 3x plus b. I'm going to substitute in my 3 for my m. Now, I want to figure out how many bottles, see, you see how 3 is an answer choice that's most likely not going to be the correct answer. How many did my artist have to begin with? Well, number of weeks. What happens if we just go backwards? What if we say my x equals 0, right? That's going to be my question, right? If I were to go back to that x equals 0, how many would my b be? Well, I don't know what my y is, so let's just go back, right? That's my goal, and let's just add. If I'm buying 3 per week, what I want to do is I want to count backwards, right? I want to try to get to that 0. So if I've got let's just go 4, 25. Let's just go backwards. 3, going back to 22. 2, going back to 19. Okay? 1, going back to 16. 0, going back to 13. There we go. I just manually counted back 3 from 4, which the lowest they gave me, all the way down to 0. Started with 13, and if we want, we can say that b equals 13, because that's what happens when x equals 0. And let's just put those in there to make sure it actually works, that I calculated this correct. Let's substitute in my 58 equals 3, my x, 15 plus 13 does 58 equals, that's 45 plus 13. Yes, it does. All right, so that is correct, and that is my b, or my y-intercept, and the answer is C, 13. Now, how did we do on this? This was kind of difficult. 36% of us were able to get this. And as you can probably guess, the second most chosen answer was actually that 3. So we're finding the slope. And that's a good first step. Calculating the slope is extremely important, but you have to know that we're wanting to get back to the start, which they never said b. They never said what happens when x equals 0. So this was a real-world situation that we had to interpret as the slope-intercept form and know that we are looking for the b. Okay? Now, the 24%, here's what's scary, got 9. This is just the change in y values in the first 2 rows. They just did 25 away from 34, and they said 9, and that was the answer. And then 9% chose this 15, and that's just the change in y variables right there. So we actually had kind of all over the place. This was 11th most difficult. I would think most likely the biggest step for our students to begin with is understanding this as slope-intercept form in a real-world situation and interpreting this as I'm looking for the b. Because if you can get to this, we would hope then that we can take the table and we can just work backwards 3 until we get to that 13. But I think the big step is trying to understand what we're even looking at. Next, for number 16, we are calculating interest. And so what we have here is we've got a deposit here, and we're looking at 8.12D, and this deposit is made into each of 2 bank accounts. Okay, so we've got the same $1,200 being deposited into 2 bank accounts, no additional deposits or withdrawals, so our principal is not changing. And we've got 1.5% interest, but one is compounded annually and one is simple interest. So I need to find the difference between these two. Okay, so let's see, do we have anything on our reference materials? Okay, so we've got simple interest and we've got compound interest. So let's go ahead and just copy both of those down. We will need that. So simple interest, I'm just going to put S sub I equals PRT. C sub I is going to equal that P 1 plus R and then raise it to the T power. Now, here's the kind of scary thing here is the simple interest simply finds me the interest. The compound interest actually finds me the entire balance. So what I want to do is I want to find both of them, and then we'll just have to put the larger one first and subtract. Okay, so let's start with our simple interest. Okay, so simple interest is going to be this. Principal, okay, $1,200. And that's it. It's not, there's nothing else on top of that. It's just the 1,200 bucks. Okay. What's my rate? 1.5%. I need to turn that into a decimal. Okay, so move the decimal over twice. I actually get 0.015. Okay, that's 1.5%. So I need to find that. And then what is my time? 4 years. All right, so let's go ahead and bring the calculator out for this one. I could use either calculator. Let's just do 1,200 times 0.015 times 4. All right, so 72 bucks. Now, think about it. How would you go from $1,200 to $72? We didn't lose money. And this is what I said at the beginning. Simple interest only gives you the interest. If you want to find out the balance of that account, you need to add back in, what did you start with? What's that principal? 1,200. Okay? So if I'm going to add that 1,200 back in, at the end of 4 years, that simple interest account has 1,272. Okay? Now let's find my compound interest. This could be my principal, 1,200, multiplied by, see that 1 plus? That 1 plus, that's what keeps my balance in there. That's why I don't have to calculate that balance again. 0.015 raised to the 4th power. Okay, so let's do 1,200. And then let's do a 1 plus 0.015. And then we're going to raise that to the 4th power. All right, so look at this. I get 1273, 63. 63,626. So we'll put a few more in there. So this one's larger, so let's take away the 1272. And what's the difference? About $1.64. $1.63,626 will raise around to the nearest hundredth. So about $1.64, there's my answer. So compound doesn't make much of a difference initially, but it's a slow burn. If you get 10 years, 20 years, 100 years, you start seeing a major difference, but not initially. So this one was extremely difficult. We had 37% get this correct. A lot of calculation there. We had 30% get B. Now you see where this 72 was, right? 72 was the amount of interest for that first one. So they just grabbed that first interest, didn't know what to do next, and figured that probably is it. Now this 25%, not that you necessarily got this, but the 7364, that's actually the interest for the second account, the one with the compound interest. And then the 180 is 9%. You can get this if you misplace the decimal when you're converting at the account one interest, but it's not very common there. So this is our 12th hardest or most difficult item on the test. Probably the most that you could do with compound and simple interest is calculating both and subtracting the two, because they do involve quite a bit of calculation, having to navigate between two, especially how the simple interest formula does not give you the total balance. It just gives you the interest, whereas the compound interest formula does give you the total balance. That's just a misconception. We need to help our students navigate. For number 17, we are looking at congruence and transformations. You see we have a match table grid, which means we just either need to say it does or does not preserve congruence. This is 8.10b. And if we know our vocabulary, we are good to go. Congruent means same size, same shape. So is a reflection going to preserve congruence? If I've got a shape there and if I reflect it over there, does that preserve congruence? Yes, it does. I'm just flipping it. If I rotate it counterclockwise, okay, so around the origin, so let me see if I were to do something like this, and if I were to rotate it counterclockwise, right, probably it would end up something like this. Yes, it's going to preserve congruence. It's just going to be pointing in a different direction. Now, a dilation by scale factor 0.5, that's what changes. Okay, so if I've got something that looks like this, a big triangle, and then if I go to a 0.5, it's going to end up being smaller. That does not preserve congruence. It does preserve similarity, but not congruence because now it's a smaller shape. So my answer is preserves, preserves, does not preserve. This one was not super difficult for students. For all three correct, you need 3 out of 3. You got 2 points. We had 57% of our students get that. For 2 out of 3 correct, you got 1 point. We had 17% of our students get that. So if you put those two together, you're looking at about 66%. So well above that 60% threshold. And either 1 out of 3 or 0 out of 3 get 0 points. You still had 26% of our students get that. But for the most part, we did fairly well with this. In fact, this is our 5th easiest item on the test. So not much to do here. It's just a matter of vocabulary. We need to know what congruence means, and then these terms, reflection, rotation, dilation. But that's the big thing, right? Rigid transformations are reflection, rotation, and translation. Those don't change anything. It's the dilation that gets introduced in 8th grade. That's the new learning, and that's what does not preserve our congruence. Next, for number 18, we are looking at 8.8. See, these are one variable equations, and in this case, we are representing it with some algebra tiles. So we've got this model here. We need to find the value of x. Okay, so there's a few different ways that we can do this, right? So what we want to do is we want to keep a balance on both sides, right? So, and I'm wanting to get a positive x. I've got some x's on the left. I got some negative x's. So what I want to do is I want to add 3 x's on this side. I'm just going to add them down here. Okay. So if I add 3 x's on this side, I need to add 3 x's on this side. I'm just going to add them up here because I've already got space over here. So if I add 3 x's on on this left side, I've got 5 x's. If I add the 3 x's on the right side, each x cancels out a negative x. So now I'm left with 5 x's and then 5 ones, and I'm left with 8 ones over here. So what I want to do is I want to take away 5 ones from each side. Once again, we're doing it in a balanced way. So take away these 5, take away these 5. Look what I'm left with. I'm left with 5 x's, and I'm left with 3 ones. So 5x equals 3, and then you could divide both sides by 5, and you get your x equals 3/5. Conversely, you could have gone just straight to turning this into an abstract representation. So I could have immediately said this was 2x plus 5 equals negative 3x plus 8. And then we could have done the same thing. We would have ended up with the same answer of a 3/5. Let's see how we did here. We had 48% of our students get this correct, so not that great. We had 24% get negative 3/5, right? So we started out correct, and then obviously we just made that sign error right there. We had 18% get negative 5/3. We had 10% get 5/3. So they ended up dividing the wrong way. Some with the sign error, some without. This one was obviously a little bit more difficult. This was the 17th, or at least tied for the 17th most difficult item on the test. And for those that like to use the pictorial representations, they can, as long as they can keep up with, needing to add in 3 x's on each side and what that would look like. If not, if we can teach our kids just to go from this representation into this equation, they might feel more comfortable using that equation as well. Either of these combinations would work. For number 19, we are looking at using the Pythagorean theorem. This is 8.7c, and we've got a right triangle here as denoted by this little square in one of the corners, and it also tells us we have a right triangle. So we're looking for the measurement that is closest to the length of the roof in feet. So really it's this side right here. Remember, the side opposite our right angle has a special name. It's the hypotenuse. We know all kinds of things about hypotenuse and right triangles. We'll get into more when we take geometry in high school. But the one thing that we need to know in 8th grade is the Pythagorean theorem. A squared plus B squared equals C squared. You see it right there at the very bottom. Now, what that means is if you take the two legs, so these are the two sides that are connected to the right angle, that form the right angle, if you square them and then add them, you're going to get the length of the hypotenuse squared. Okay? So what that means is if A is 18, that means 18 squared plus 8 squared equals C squared. So we're going to need to square both of those. So let's go ahead and do that. So let's do 18 squared. And then let's go ahead and add 8 squared. Let's do both of those together. Okay, so that's going to get 388, which is not an option. It's not meant to, is equal to C squared. Now, what we need to do is we need to take the square root of that square because that cancels it out. Just like multiplication cancels out division, addition cancels out subtraction. Taking a square root of something is what cancels out or reverses, or is the reciprocal of a square. So let's take the square root. So we're going to hit that second button, and then we're going to get the square root, and we're going to do 388, and we've got this 19.697, so 19, let's call it 19.7. And that is our answer D. So if we knew the Pythagorean theorem and how to use the calculator, that'd be pretty simple. And honestly, it was pretty simple for our students. We had 65% of our students get this correct. So while that might not seem like much, that's well over that 60% threshold. Should feel pretty good about that. 20% chose C, 26 feet, and that's simply, look what we're doing here. We're adding 18 plus 8. So there's still 20% that have no idea what to do, but they took two numbers and added and thought that was it. And then we're getting 10% on 16.1, and then we're getting 4% on 5.1. There are ways to get that, but that's pretty close to statistical noise. So this is tied for our sixth easiest, and so that's just another opportunity for us to continue to have our students clue into when we're dealing with a right triangle, we should be thinking of the Pythagorean theorem. That's probably going to be what we're going to use to solve for a missing side length. For number 20, we are looking at transformations on the coordinate plane. This is 8.10c, and we don't have any visuals, but we can draw one if we need some. We have a square ABCD, so let's just put a square right here. All right, so let's just put A, B, C, D. All right, translated 3 units to the right on a coordinate grid. So let's say that it's not very far, so we're going to go like this. It's going to end up overlapping a little bit because it didn't go over enough to kind of clear that other edge. And that's going to get A prime, B prime, C prime, and D prime. So which rule describes the transformation? Well, notice that all the rules start with xy. So this is going to be our just starting point. So let's just pick some values for A. Let's say A was 2, 2. If we moved it 3 to the right, the y value did not change, but our x value is going to increase by 3. So that's going to be 5, 2. Right? We could do the same thing for D. Let's say our D was 2, comma 5. It's going to move 3 to the right, so that's going to end up being 5, 5. So what are we talking about here? Well, we're talking about an increase of the x value by 3. And really, we've got 4 choices here. We're either increasing or decreasing the x value or the y value by 3. And when we move to the right, that's our clue that we are increasing the x value by 3, and that is our answer C. Now, we did pretty well on this one as well. 63% of our students got this one correct. So that's pretty good. And then the one that really kind of threw us for a loop was this, look at this, 24% chose B. And that's just just switching the coordinates in translation. Instead of increasing the x value by 3, they're increasing the y value by 3. So we know that to the right means the plus, so that didn't necessarily mess them up. We only had 6% of our students choose D, which still maintained the x value, but they just decreased it by 3. Not really anyone chose that one. 7% chose A. Really, the tripping up was if we're going to the right, we know we're increasing, but we still had 24% of our students switch the x value and the y value. And that's, once again, needing to just reiterate which direction the x value moves, left and right, which direction the y value moves, up and down. And to the right or to the left means the x value. This ends up being our 9th easiest item on the test, and it's above that 60% threshold. So for the most part, we are pretty pleased with this. For number 21, you see we've got a multiple select, so it's a 2-point problem here. We've got some options down there, and our graph doesn't quite fit. So we're going to do a little bit of scrolling here. Take a look at what we have here. We have a segment, and we want to show that y is a function of x. Now, the fact that they give this to us means that's kind of important, that they're labeling this not just a line segment, but it is a function. Y is a function of x, y is a function of x. Now, what does that mean? Y is a function of x. Well, that means that each input has exactly one output. So our inputs are our x's, and our outputs are our y's. So each x goes to one y, which is going to be the case here. We've got two options here. One option would be to just plot these extra points, and I think we got 5 extra points, so we can plot those. Another option would be to extend our line and see which one works. So let's do a little bit of both. Let's first plot our points, and I'm just going to use this add point feature, and I'll do it in blue. So 3, -6. So 3, -6 is kind of right down there. And let me reset this and get it off the grid size. There we go. So 3, -6 goes right there. I've got a -1, 6. Now that's going to kind of go up. So I need to bring this up a little bit. -1, 6. Now notice the problem with that -1, 6. If I've got that -1, 6, I've got an x value, -1, that goes to 2 points. I've got -1, 2, and I've got -1, 6. So this is not going to work. This could work. And that's the definition of a function. Each x only goes to one y. Let's go to 1, -6. So 1, -6. Another problem right there, because I've got 1 goes to -2, and then 1 goes to -6. So 1, -2, 1, -6. That's not going to work. Now I've got a 0, 2. That's not going to work because take a look, I've already got a 0, 0. So if I've got a 0, 0 and a 0, 2, that is going to be not a function. So then my last one down at the very bottom was supposed to be that -2, 4. So let's get everything back in line there. -2, 4. -2, 4 could work. And you see how that's going to be kind of by itself. So the two that actually work are that -2, 4, and then that 3, -6, the top and the bottom. Now, another thing we could have done is we could have just done the connect line feature. And we could have just extended our lines here, either direction. And you notice that the lines extended are going to hit two of these points, the two that we did, the top one and the bottom one. So those two are going to be our answer, the 3, -6, and the -2, 4, because they have points on that line that are going to make each x have its own y, or each input have its own output. So this was a 2-point problem. So we had 42% get both points correct. We had 46% get 1 point correct. So if we take half that 1 point, that's 23. So that's going to end up being 65% overall correct, which is above our threshold. So this is pretty good. In fact, this is the tied for the 6th easiest item on the test. We still had some students not get any points correct, but only 11%. So that's actually pretty good. Our options here, our answers here are option 1 and option 5. And so next we are looking at Pythagorean theorem on a coordinate plane. This is 8.7d. Now this one is a little bit trickier because it's not as explicit. We've got 2 points shown on the coordinate grid. Now let me show you the quick and easy way that students are getting this wrong. Because when I say Pythagorean theorem on the coordinate grid, that's not labeled anywhere. That's just what I call this particular standard as a shortcut. All we're seeing here are 2 points on the coordinate grid, and I want to find the distance between points K and point L. Well, if I'm not paying attention, I can just count diagonals. 1, 2, 3, 4, 5. That is what most of our students chose. I'll go ahead and give you this. 45% of our students chose that. That is the most chosen answer. That is not the correct answer because a diagonal is going to be slightly longer than each of the side lengths, even if it's a square. That's what the Pythagorean theorem tells us. The hypotenuse is always going to be the longest side of any right triangle. What we need to do is we need to view this as a right triangle. So if I draw an imaginary line there, if I draw an imaginary line there, look what I've got. I have a right triangle. And I can say that this leg is 1, 2, 3, 4, 5. And this leg is 1, 2, 3, 4, 5. Now, it's not going to work if that hypotenuse is 5. But once I have myself a right triangle, I can use my a squared plus b squared equals c squared. These are going to be my a's and my b's here, my 5's. So 5 squared plus 5 squared equals c squared. So let's pull that out here. And let's do 5 squared plus 5 squared. Okay, that equals 50. It's 25 and 25. That equals 50 equals c squared. Now, how do I unsquare the c? Well, the inverse is going to be a square root. So let's take a square root of 50, and you're going to get just a hair above 7, because 7 squared is 49. So c equals about 7 units. And that is our correct answer. But that was extremely tricky because you first had to recognize that this was the opportunity for students to draw a right triangle and use the Pythagorean theorem to count the length of this diagonal. We only had 32% of our students choose this, so much less than the 45% that just thought they just want me to count 5 spaces. Like, this is not an 8th grade problem. Count the spaces between K and L. Students that thought it was that easy should have known that there was some type of trick, something they were missing. Now, we did have 21% of our students choose C. And what they could have done here is they could have used 7 as each side length here, right? Because it's 7 away from this axis, 7 away from this axis, not necessarily 5 from the angle that's joining them. And then only 2%, you know, got that 20. That's if they multiplied the legs by 2 rather than squaring them. If you got all the way to actually drawing the triangle, you're probably going to square them. You're not going to multiply by 2. This was difficult. In fact, this was our 9th hardest item on the test. And you see the huge misconception of just thinking we can count diagonals. And this would be an opportunity for students just to get some larger squares and just measure them. Get a ruler and just see that the side lengths of the squares are going to be slightly smaller than the hypotenuse. And if they can just measure that with rulers, they can, start to internalize that understanding that you can't just say, oh, the hypotenuse or the diagonal is going to be the same length as the sides. It's not. For number 23, we are looking at direct variation. This is 8.5e. And we have a verbal description here. The value of y is directly proportional to the value of x. That's why I call it direct variation. When we say it's directly proportional, we're going to see this right here. Direct variation, y equals kx. So let's put that in here. That's going to be important. Y equals kx. It's not slope-intercept form, because slope-intercept form is the y equals mx plus b, and that b means it's not a directly proportional, because that b is going to change it and push the graph up or down. So when x equals 3/4, so let's just use the substitution, y equals 56 1/4. Okay, so I'm going to put my y as 56. I'm going to go ahead and do a decimal here, 0.25 equals k times, and that 3/4 is 75 hundredths. So what is the value of y when x equals 1/2? Well, I need to solve for this k. If I can solve for this k, then I can plug this in and get this. So if I want to isolate that k, I'm just going to divide both sides by that 75 hundredths. So let's pull out our calculator here. And let's do 56.25 divided by 0.75. Oh, 75. Okay, so 75 equals k. So now I can plug that back in here. I'm looking for what is the value of y when x equals 1/2. So y equals my k is 75. And then my 1/2 is just going to be my x, so 0.5. So let's just do that times 0.5. And what do we get? 37.5. Or 37, I'm guessing they're going to want us to do a half since everything's in fractions. And there we go. Our answer is B, 37.5. Now, how did we do? That one, we actually did fairly well. Students were able to follow along with it. Just a hair underneath our threshold of wanting to at least get 60%. We got 59%. We got 21% of our students got tripped up by C, 56, and that's using an additive relationship, right? So that's when they took this 56 and a fourth, and they just kind of subtracted that 1/4, and that was pretty close to that. It's not exactly right. That'd be 53 and 3/4, but they just subtracted these two and thought that was the closest, which that's not how it works. A, we had 11%. And then, so you see the 75, they found the constant, right? A version of the constant. Our constant was 75 hundredths. They just found 75 and thought that was what they were looking for. And then 9% are doing some other kind of crazy stuff to get that 84 and 3/8. So this was tied for our 13th easiest. Overall, not so difficult for students. The key here is recognizing that when we're talking about, and when they tell you that y is directly proportional to the value of x, you need to pull out that y equals kx. And if you can do that, you'll be good. For number 24, we are calculating interest. This is 8.12d. And the only challenge when we're calculating interest is to make sure that we're using the correct formula. So let's see if we can figure out what we have here. We have a deposit. And we've got simple interest. There we go. So let's pull out our simple interest formula here. I equals PRT. Now, remember, when we're dealing with simple interest, it's just getting me the interest rate. It's not getting me the actual balance. So the challenge here is it's going to ask me what is the balance, but the I equals PRT just gets me the interest rate. So first let's find the interest rate. I equals PRT, the principal is the P. So what's the amount that we're building interest off of? 79.12. What is the rate? 5.75, but I need to turn that into a decimal. So that's 0.05, because this is 5 parts out of 100, so I need that 5 in the hundredths place. And that 75 goes into the thousands in the 10,000ths place. And then the time is 2 years. All right, so that is how I'm filling that out. So let's get our calculator working. We've got 79.12 times 0.0575 times 2. Now, $909.88. That is not an option because that is simply the interest. If I want to figure out what my balance is, I need to take my interest and I need to take that back to my principal, which was that 79.12. So let's add 79.12 back into that, and it's going to equal, so the balance equals the interest plus the principal, 8821.88. If I'm rounding to the nearest dollar, it might be 8822. And that's what we're doing. We're rounding to the nearest dollar, 8,822, 8,822. Our answer is C. Now, we actually struggled a little bit on this one. We had 48%, only 48% get that correct. We had 21% choose A. So we kind of got messed up on A. And so what we did here is we multiplied the interest rate by 2 and then used I equals PRT. So we ended up doubling the interest rate for some reason because we do have to multiply this by 2, but we double the interest rate and then put it back into the PRT. So we ended up over calculating. We had 16% choose B. So in this case, we multiplied the interest rate by 2 and then added it to the principal. So they added this rather than multiplying it. And then some students did way too much work. They used compound interest, only 14%, but this is the compound interest. And you notice it's not that much difference. Compound interest doesn't make that much of a difference if the time span is extremely short. So this was tied for our 17th most difficult item on the test. So definitely a little bit more on the difficult side rather than on the easy side. For number 25, we are looking at surface area. This is standard 8.7b. And we have the toy box here. We simply need to find the total surface area, and we don't have A, B, C, or D to choose from. We need to type it into this equation editor. So let's look at our surface area on a reference material, and we'll see surface area. This is a prism since it's a box. So we're looking at total surface area. So what we're going to do is we're going to put this S equals PH plus 2B. Now that's going to get us the start, but we still need to know what this means. Okay, so this P right here stands for the perimeter, and then the H is, of course, the height. So let's fill in the rest of this box here. And since it's a rectangular prism, we can choose, they're all going to be rectangles. Let's choose this right here, and then this right here as our two bases, okay? So what is the perimeter of this base? Well, if I were to think about the perimeter of this base, this is going to be 40 plus 40 plus 34 plus 34. Or I can do 2 times 40 plus 2 times 34. That's going to give me my perimeter of all 4 sides, and I'll do that in blue here. along the base. All right. Now, if I take that perimeter, then I multiply it by the height. So what I need to do here is I need to put some brackets. Going to multiply all of that by 30. What that's going to end up doing is that is going to end up getting me the area of these four connecting rectangles. The two sides, and then the one in the back right there. Because that perimeter is going to be the length, and then the width, if I'm doing just basic area, length times width would be that height of 30. So this is taken up with this right here. Now I need to add 2b. Now this big B right here is the area of the base. So what is our base? Well, it's the same 40 times 34, but I need to double that because there's a base on the bottom, a base on the top. So 2 times 40 times 34. So that's a lot. Let's get our calculator out and let's plug that in. All right, so we're going to do 2 times, and you know what? Let's clear that out. Let's put the opening bracket there so I can get that 30. Okay, so 2, and then I've got my 40, then I've got my double the 34. It's going to give me my perimeter. Now I put that other bracket. I want to multiply all of that by 30. So that's the perimeter times the height. And then what I need to do is I need to add the double the base. So 2 times 40 times 34. All right, 7,160. That is the correct answer. So 7,160 square inches. So now all we need to do is just type that in. 7,160. Now that was a very difficult problem. In fact, this happened to be the second hardest, or tied for the second hardest item on the test. And I think part of it is because it is obviously not multiple choice. It is a free response or equation editor, but also this isn't what we would typically consider a regular rectangular prism. A lot of times we're thinking of like, big tall boxes where the bases are very clear, right? You can easily see, all right, top and bottom of the base, but this is almost a cube, not quite a cube, but almost a cube. So it's kind of hard to distinguish, well, what's the base and what's not the base. And obviously we've got a lot of numbers to type in here, a lot of parentheses. So this tied for the second hardest item. We only had 24% get, this is a 1-point problem, 24% get this correct. 24%, that's slightly less than guessing. 75% get 0 points. So this one was definitely challenging for our students, but very closely mimics what you would see in a traditional classroom where you just have to find the answer on your own. For number 26, we are identifying proportional and non-proportional functions. This is 8.5H. And we have just some equations here. We need to find a proportional relationship. Now, if we know what a proportional relationship is, then this is going to be very easy. If we don't, let's go ahead and graph this, because that is also an option. So let's get our Desmos here, and let's just plug some of these in and see maybe if that will help us see what's going on here. So I want to just type this in here. I'm going to do y equals x plus 15. And like I said, if we know what proportional means, this is pretty simple. If we don't, graphing is always a good option. Let's see if we can visualize something. X divided by 2. All right, now we're going to have y equals 2, and then x plus 4. And then finally, we are going to see y equals 5. So that is going to be a straight line. All right, so if we don't know what proportional is, right, they're all straight lines, but we should notice that only one of them goes through the origin, which is really what we're looking for. We're looking for the line that's proportional, which means it goes through the origin, and it's this blue one right here. This y equals x over 2. And it's because we have this in the y equals kx. Now, they hid it a little bit. Instead of y equals kx, what they did was y equals, and then that k ended up being the 1/2, right? That 1/2 x. They just kind of hid that so it looks like x over 2, but that's what that k is. And that's direct variation. That means it goes straight through the origin. All of these are in the slope-intercept form, which means we have a y-intercept. This is, if you distribute this out, you're still going to get y equals mx plus b. And then this, we saw, was a vertical line, right? So it doesn't necessarily have any slope at all. And so we are going to have B as our correct answer. That is the one that goes through the origin. That's what it means to be proportional. So let's put that there, through the origin. This one, no visuals, unless you put them on the graph. Now, if you put them in Desmos, maybe that helps, maybe that doesn't. Only 31% of our students were able to get this correct. 30%, which is not very different, chose A, right? So they thought proportional meant an additive property. And then we've got 25% chose C, right? So we're getting pretty close to guessing. The one that really kind of fell off here was that D, y equals 5. It definitely is different, but it's not what we need. And so we're pretty close to guessing right here, which is not really what we want. This is actually tied for our 7th most difficult item on the test. Obviously, we can talk to our students about graphing this on Desmos, seeing if that helps, but this all comes down to vocabulary. Proportional equals through the origin equals this format. Y equals kx, no plus b, right? That's the slope-intercept form. If we can get that vocabulary for our students, then you can honestly do this without even graphing it. Next, for number 27, we are looking at scientific notation. This is standard 8.2c. And we've got a little bit of a verbal description here, but it doesn't really matter. We're just looking at this. We want it in scientific notation. Now, here's the thing with scientific notation. Scientific notation is always a number, and it's going to be between 0 and 10, okay? Or actually, it's going to be between 1 and 10. So we need something in that ones place, okay? And then we can have something, as many things as we need to in the tenths, hundredths, or whatever. But we do need something in that ones place that is greater than 0. So if I were to put this 15,300, right? If I were to put that out there, and then obviously if we make that a decimal, we don't really need these two, but we're going to have those for places. What did I do? Well, I started with 15,300, and I moved the decimal once, twice, 3 times, 4 times. Okay, so I moved it 4 times to the left to turn it into this. So if I wanted to get it back to this from this, I would need to move it once, twice, 3 times, 4 times to the right. And so that's what we're going to do. We're going to label this as 1.53 times 10 to the 4, because every time I jump to the right, I am adding 1 to that exponent. And so that is going to be our answer right there. If I were to do this, 1.53 times 10 to the negative 4, this is what it would be. 1.53 times 10 to the negative 1, 2, 3, 4. Negative 4 gets you smaller. And that's not what we're looking for. So we had to kind of reverse engineer it to get it to the 1.53. And then it's going to be times 10 to the 4th. Our answer here is C. We did fairly well on this. We did 56% of our students got this correct. Not quite at our 60% threshold, but also pretty decent. Now, what tripped us up here, look at that. This also technically gets you to the correct answer. If I did my 0.153, and we can plug that in the calculator if we need to. 1, 2, 3, 4, 5. So that gets me back to my 15,300. But we need something in that ones place. When we're showing something in scientific notation, this ones digit needs to be a 1 through 9 in that ones place. Has to have something up there other than a 0. That's just the way scientific notation works. So even though this does get you to that correct answer of 15,300, it's not correct scientific notation. So that is a huge misconception that we should be able to easily work with our students. And this is tied for the 15th easiest item on the test. So kind of towards the middle, but a slightly more towards the easy side for our students. For number 28, we are looking at dilation representations. This is 8.3c. And we have a pentagon here, and then it's being dilated. And all we have is the new vertex. So we have all of this right here, but really we're just looking at R and then R prime. Where's R prime? R prime is 6, 2. So R prime goes right there. So I'm thinking we're shrinking it a little bit here. So how do I best describe that? I don't have any of the other coordinates, but I don't really need it. All I need are 2. So let's look at R, okay? R is 9, 3. And then they gave me R prime as 6, 2. So I did get smaller, right? Now, how could I show that? How can I find a scale factor that's going to get me down, right? So if I know that I'm getting smaller, I know that that's going to get me larger. Even that is going to get me larger, the 3/2, because that's over 1, right? So what I could do is I can take my new values, right? And I could divide that by my old values. And you see that we're both equal to 6/9 or 2/3, and really that 2/3 is going to get me my scale factor, right? If I take my 9 and I multiply it by 2/3, I'm going to get 18/3, which equals 6. If I multiply my 3 by 2/3, I'm going to get 6 over 3, which is going to equal 2. All right, so there we go. We have our scale factor of 2/3, and we were able to at least eliminate B and C, just because they were going to get us larger. And we saw with R prime being closer to the origin, we're shrinking a little bit with this dilation. So our answer is D. Now this was difficult for our students. We only had 28% of our students get that correct. So just a hair above guessing. We had 27% and we had 27%. So look at this. The one that really didn't trip us up too much was B. We only had 18%. But this is all about guessing. So when we are working with dilations, a lot of times we'll get 2 brand new shapes. But we need to work with our students with just a pair of vertices, the original and then the dilated vertex. Once we have those two, it's all about proportionality and trying to get from 9 to 6 and 3 to 2 and finding that scale factor. That's where we need to do a little bit of work and practice with our students, because this was tied for 4th most difficult item on the test. So that was definitely difficult. And you see from answer distribution, we are just guessing. We know it has to do with 3 somehow. We know it doesn't necessarily get us any larger, but other than that, our students were kind of guessing all over the place. For number 29, we are looking at slope and y-intercept. This is 8.4c. You notice we have inline choice, which means it's a 2-point problem. So we have a table of values here, and we just need to find the slope and the y-intercept. All right, so If we need it, we can find our slope right up here. Slope of a line is m equals change in y over change in x. So let's do that. M equals change in y over change in x. Doesn't really matter which y's and x's I use as long as they are paired up together. I'm going to do this as my y sub 2 and y sub 1, just because looking at 31.5 and 21.5, they're 10 apart. It's going to make it kind of easy. So I need to make this my x sub 2 and my x sub 1. You just need to match your x sub 1 with your y sub 1 and so on and so forth. All right, so my y sub 2 is 31.5. My y sub 1 is going to be 21.5, right? So that's going to equal 10. Chose those because they were easy to work with. And then I've got an 11 minus 7, so 10/4, right? So that is going to be, if I cut both of those in half, right, I get 5/2, or 2.5. Not sure what they're going to want me to do in regards to a improper fraction or decimal. So that is my slope. I'll stick with that 2.5. Let's see what we have here. There we go. Got a 2.5. Now I need to find the y-intercept. So let's go back to our slope-intercept form. Y equals mx plus b. We know what our m is, 2.5. Now let's plug in an x and y. Let's do any of them work, but let's just put this 5 right here. Let's put our 16.5, and now all I need to do is solve for a b. Okay, so this 2.5 times 5 is going to be 12.5 plus b, and then we're going to subtract 12.5 on both. We're going to get b equals 4. All right, so our slope is 2.5, our y-intercept is 4, and if we want to double check our work, we could plug, any of these values in right here, and we would get that same answer. We would get the true values if we plug that in. So this was a 2-point problem, and we had 41% of our students get both of these correct. We had 24% of our students get one correct. We don't know which one. My guess would probably be the slope, because there's a direct equation for the slope. You have to kind of use substitution to get that y-intercept. That's probably a little bit better. We take half of that 24%, we're looking at 53% correct, so not horrible. And 35% got 0 points, so we still have a third of our students that are still unable to access this. So this was the 18th easiest, or tied for the 18th easiest item on the test. And so not too bad, but obviously we still have a little bit of meat left on the bone. For number 30, we are looking at volume. This is standard 8.7a, and we have a cone here, not pictured, that has a radius of 12, height of 18, so we need the volume of this cone. So let's first get that volume formula, and if you don't remember it, you can always use the reference material. Volume of a cone, I'll put it right there at the bottom of the screen. V equals 1/3 base times height. That's the same formula that we would use for a pyramid or a cone. So we will need that. V equals 1/3 base times height. So here's my cone. Let's visualize it here. So I've got a radius of 12, and I've got a height of 18 centimeters. All right, so let's see what our formula is. This B is always the area of the base. And when we're talking about a cone or a pyramid, we're talking about the flat part that the object sits on. So the area of this, the cone happens to have the base of a circle. So I need the area of a circle formula. And if you forget that, it's right here. That's A equals pi r squared. So I'm going to substitute in this B for pi r squared. And I'm going to bring everything else back down. V equals 1/3. That base is pi r squared, and then I still need the height. Now, before I get too far, take a look at our answer selections. they actually want the exact answer, not an approximation. Sometimes they will say an estimate or the closest to, but that's because we use 3.14 as an estimate, or we'll use the pi number, but we'll still end up rounding it. So when we want the exact volume, we have to keep pi in our answers, which means I don't need to simplify pi. So I need to simplify everything else, but I need to keep pi separate because pi is going to show up as a part of my answer. So let's start substituting. So volume equals 1/3. I'm going to keep that pi in there. What's my radius? My radius is 12. 12 squared. And then my height is 18. So I'm just going to go ahead and do that right there. What is 1/3 times 18? I'm going to rearrange that. I can use the commutative property to rearrange anything I'm multiplying. So 1/3 of 18 is 18 divided by 3, so that equals 6. 6 pi, and then 12 squared happens to be 144. So I just need to multiply 6 times 144. I can do that with calculator, or I can do it longhand. That's 24, that's 26, 864. So volume is going to equal 864 pi. And if I want to get an approximate, I can actually put that in the calculator and round it. But our answer here is C, 864 pi. Now, that is a little bit different because we included pi in our answer selection, so that might have messed up some of our students. Only 38% of our students were able to get that correct, so that is extremely low. We had 26% of our students choose A, which is the volume equals base times height. They took the formula for volume of a cylinder, not a cone. So what they didn't do is they didn't multiply it by 1/3. Then we had 25% choose B, right? And so B is 25%, and that's not even volume. That's area equals, that's just pi r squared. They just took that 12, right? Doubled it, or squared it to 144 and got that. And then if most of us didn't necessarily fall into this trap, but if you just took the radius and you multiplied it by, or if you squared the height rather than the radius, you squared the wrong thing, you can get D. This one was difficult. This was the 13th hardest item on the test. Not only did we not have a cone pictured, right, we had to select the correct formula, the 1/3 base times height, but then we also had to keep pi in our answer. And if you just multiplied everything out, you're not going to find that answer. You're going to find an answer that's close to A. It's going to end up being like 27 something, but not quite. And so that might have thrown some of us off. Next, for number 31, we are looking at modeling the slope-intercept form. This is 8.5i. And we've got a verbal description, a real-world scenario. We've got a bakery. We've got a $5 flat delivery fee. And then we've got $20 for delivering 12 cookies. We got $27.50 for delivering 18 cookies. Okay, so we're trying to figure out the total charge for delivering X amount of cookies. Well, what do we know so far? Okay, well, we know that we've got a slope-intercept form here because I see a flat delivery fee. Whenever we see a flat delivery fee, that's an unchanging constant, right? So what I have here is we've got a total. So what is our total? Well, our total is our y. So if I were to do a table of values, I can say our total is going to be our $20 for 12 cookies, and that's going to be our x number of cookies. And then we've got our $27.50 for 18 cookies. I know what my b is because it's a $5 delivery fee. So y equals mx plus 5. So what I need is I just need to figure out what my m is. What is my slope? Well, how could I figure out my slope? Right? Slope of a line is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Change an x over or change in y over change in x. And I've got two y's and I've got two x's. So let's just label this my y1 and my x1, and then my y2 and my x2. And if I subtract those, all right, so I've got 2750 minus 20 over 18 minus 12. That's 750 over 6. So let's divide that real quick. Okay, so I've got 750 divided by 6. It's going to be 125. All right, so that equals $1.25 per cookie is what I'm thinking. So here's my thought. 125 x plus 5. Now let's double check. If I put in 12 right there, will I get 20? So let's do 1.25 times 12 plus 5. Yep, I got my 20. What if I do 18? 1.25 times 18 plus the $5 delivery fee, 27.50. Okay, so there's my answer, 125x plus 5. And we see our answer right here as A. Now, how did we do on this one? Not too horrible. We had 54%. So over half get A, not quite 60%, but decent. We had 21% choose B. You see what we did here. We ended up getting the correct numbers, the 5 and the 1.25. We just ended up switching them. We thought that $5 delivery fee was the rate, which obviously it's not. And then we're getting close to statistical noise down here, 12% for C, 12% for D. So this was fairly easy. In fact, this was the 17th easiest item on the test. Once students were able to recognize this as looking for the slope, the rest kind of solves itself. For number 32, we are looking at linear relationships. This is 8.5C, and we've got scatter plots here. And we need to find a non-linear relationship between x and y values, okay? So non-linear, if we don't know what that means, let's just, I'm going to take the grid size off here, and I'm going to use the connect line feature. Let's just connect lines. Let's just connect trend lines. Okay, so I can do a straight line to connect that. Going across, I can do a straight line to connect that. For the most part, I could do a straight line to connect that. But take a look at this D right here. I can't do a straight line to connect that. I would need two straight lines is what I would need. And so that's the one that's different. So even if you're not sure what nonlinear means, and linear means line, you see the word line in there. So nonlinear means non-line. And this is something you're actually going to get into in Algebra 1. This is an exponential function. It's where the x is actually in that exponent form. And so that exponential function is what graphs like that. It ends up sloping up really high, and then it goes on forever. So that is the nonlinear function. That is our correct answer of D. And that one was pretty good for our students. We had 60% of our students choose that. So that's that threshold that we're looking for, 60%. We had 17% choose C. It's not necessarily a slanted line, right? We're not necessarily seeing a slope. It's a straight line. That might have thrown us off. And then we had 15% choose A. Not sure why that would mess us up. Maybe the negative slope, right, was nonlinear. And then B was the least chosen, and that's the most like a line that we've looked at in 8th grade. It's just that positive slope moving up. So this was fairly easy. In fact, this was the 12th easiest item on the test. So we did fairly well on this one, and our students should be fairly proud. For number 33, we are using the Pythagorean theorem. This is 8.7c, and you notice this is a drag and drop. So we need to have two out of the correct 3 to get 1 point, all 3 correct if we want to get both points. So let's put that down there. 2 points equals 3 correct. It's a 2-point problem. 1 point is only 2 correct. If you get 1 correct or 0 correct, you get no points. Obviously not what we're looking for. So 0 or 1 correct. So we need to simply decide whether each triangle with set of side lengths is a right triangle or not a right triangle. And so obviously one answer is going to be used more than once because there's 2 possible answers. It is either is a right triangle or not a right triangle. And there's 3 answer selections. And what we need to use here when we think right triangle in 8th grade, we always need to go to the Pythagorean theorem. A squared plus b squared equals c squared. So let me draw us a sample right triangle here so we can visually have something to look at. Let's see if I can connect this here. There we go. All right, so let's do our first one. I'll do that in black. So 6, 8, and 9. The longest side is always the hypotenuse. Okay, so let's do 6, 8, and 9. Here's my question. Does 6 squared plus 8 squared equal 9 squared? Because my Pythagorean theorem says I need a squared plus b squared equals c squared. If I add these two, it's going to equal that right there. Well, no need to guess. Let's see. Let's just use the calculator on this. So 6 squared plus 8 squared. If I need to know it, I can use 9 squared, but 9 squared is 81. That's 100. So 6 squared plus 8 squared does not equal 9 squared because 100 does not equal 81. So on this first one, we will say it is not a right triangle. And then let's repeat the same one. So let's use 10, 24, 26. So I'm going to just replace this with 10. 24, it's not drawn to scale. 26. So here's my question. Is 10 squared plus 24 squared equal 26 squared? Remember, the hypotenuse is always across from the right angle, always the longest side. So 10 squared plus 24 squared equals 676. Now, I don't know what 26 squared is, so let's go ahead and do that. 26 squared, hey, 676. So that is a right triangle, so we're good there. And then let's look at our last one here. And we can look at 24 and 45 and 51. So the question is does 24 squared plus 45 squared equal 51 squared? So 24 squared plus 45 squared, 2,601. What is 51 squared? Same thing, 2,601. All right, so that is a right triangle. So that is going to be our correct answer set. Not a right triangle, right triangle, right triangle. So how did we do on this? Well, we had 46% get 2 points. We had 20% get 1 point. We don't know which one that they kind of messed up. My guess is maybe a student just picked right triangle for all 3, and they would have gotten 2 out of 3 correct, but we don't know. We don't got data for that. We take half of the 20% as 10%, so we're going to end up with 56% overall correct. So not necessarily horrible. And we had 34% get 0 points. And this is just a straight application of our Pythagorean theorem, but this ended up being tied for our 15th easiest item on the test. So for the most part, pretty good. The hardest part, of course, is just recognizing that this is a right triangle problem needing the Pythagorean theorem. For number 34, you notice we're going to have to scroll here. We've got 2 graphs. We've got 2 table values. We are representing linear proportional relationships. This is 8.5a. We need to find which graph or table shows a proportional relationship described by the function y equals negative 2x. Okay, well, y equals negative 2x. I can easily plug that in here, right? So let's plug that in. There's several different ways to solve this one. So if you solve it a different way, that's fine. I'm going to go ahead and graph this here. Let's bring this over here, because if it's one of the graphs, that's going to be pretty easy. Let's just do y equals, and then we'll do negative 2x. Okay, so we've got that negative slope there. So it's definitely not A, because it's got a positive slope. Could possibly be B. Okay, so let's see, let's get a table of values there. And so we're looking at negative 2, 4. Okay, we're looking at negative 1, 2. We're looking at it's proportional 0, 0, 1, negative 2. Okay, so this matches our table of values. So I'm thinking it's B, but let's just verify to make sure that this table of values doesn't match C or D. And you notice how on Desmos I've got negative 2, 4, but this has got negative 2, 2. That's wrong. And this one's got 2, negative 1. Or this is 2, negative 2, not 2, negative 4. So this is completely wrong. Same with this. This is 2, negative 1 rather than 2, negative 4. Okay. So both of those are incorrect. And so B is our correct answer. And we were able to graph that and able to see that, verify with the table of values. And so let's see how we did here. So the correct answer is B, and we had 47% choose B. So not necessarily wonderful. We had 20% choose A. Now we had 26% choose C. So there's something in C that really messes up. And really what this is y equals negative x, right? 2, negative 2, 4, negative 4, 6, negative 6. That would work, except it's y equals negative 2x. So we didn't quite get that coefficient there. And then if we look down at D, right, we can put D right there. That was a very small 7%. And I looked at y equals negative 0.5 or 1/2 x rather than half x, than 2x. So this ended up being our 16th most difficult item on the test. But if we can get the kids to open up their Desmos or even their TI-84, graph it visually, we can start looking at some things, and that could help us find the correct answer fairly quickly. For number 35, we are looking at transformations on the coordinate plane. This is standard 8.10c, and we need to find the rule that describes the transformation of a 270 degrees counterclockwise rotation. Now, rotations and reflections involve a lot of just memorizing rules, but there are some that are a little bit intuitive, right? So let's go ahead and knock out the ones that are intuitive. So let's say I've got a shape that's right here, okay? And if I wanted to reflect it across the y-axis there, what's going to happen is my x is going to become my negative x, but the y stays the y. So that's what we have right here. So this is a reflection across the x, or excuse me, the y-axis. We're not looking for that, so we're going to cross this one out. If I wanted to reflect it down, so let's do that with a different color here. Let's say we're going to reflect it down. You notice my x stays the same, but my y becomes a negative y. So that's what we have right here. So even without memorizing a bunch of rules, we can just kind of reason through a few of these. That's going to reflect across the y-axis. We don't want that. So we're stuck with these two, where they end up swapping the x and the y coordinate. So this is the one where we need to end up memorizing a little bit. So let me draw a new shape here. Now, 270 degree counterclockwise. So let's talk about what that means. Counterclockwise means against the way of the clock, right? So this is 90 degrees counterclockwise. This is 180 degrees counterclockwise. So this is 270 degrees counterclockwise. One thing that we need to remember is that 270 degrees counterclockwise is the same, if I'm going the way of the clock, is the same as a 90 degrees clockwise. So if we can memorize that, 90 degrees clockwise equals 270 degrees counterclockwise, well, then I don't need to remember a whole bunch of separate rules. I need to remember a few different rules. Okay? So if I'm going 180 degrees either direction, clockwise or counterclockwise, that's pretty easy. X, Y, you just flip everything. Negative X, negative Y. If I'm going 90 degrees counterclockwise, that's this right here. It's the same as 270 degrees clockwise. What I'm going to do is I'm going to flip my X and Y. So my Y comes first, my X comes second. Now, this is not going the way of the clock. So you're going to go ahead and put your first variable, what was your X, now it's your Y variable, that becomes a negative. That's not the one we're looking about. We're looking at the 270 degrees counterclockwise. I want you to see the similarity between these two. If I'm doing this 270 degree counterclockwise, which is the same as 90 degrees clockwise, we're going to do the same thing. We are going to take our X and our Y. We're going to flip them. They become Y and X. Now, the second variable becomes negative. And the way I remember that is because this is the way a second hand moves in a clock. The second hand moves clockwise. So if I'm going clockwise, the second variable becomes negative, and that's actually the one we need. You notice how both times we go to a 90 degrees either clockwise or counterclockwise, the X and the Y variables swap. The difference here is when I'm going counterclockwise, the first variable becomes negative. When I go clockwise, the second variable becomes negative because that's the way a second hand moves on a clock is clockwise. And so that's the one we're looking for, and that is D. Now, that's a lot to remember. It's a lot of associations, and this is the most difficult item on the test. Only 21% of our students got that correct. That's less than guessing, which means our students were trying. But look what we got, 23%, 26%, 29%. So the most chosen answer was they were getting close. They knew something had to swap, but they chose the 90 degrees counterclockwise. We should have been able to eliminate these two even if with just a little bit of reasoning, knowing that they reflect. This is a little bit difficult to just kind of map out on your own without necessarily plotting some points. Obviously, we could have plotted some points and we could have put them into the calculator and just kind of visually seen what happened. But this is the first hardest item on the test. As you can tell by our answer distribution, most of our students were guessing, and they ended up guessing incorrectly, and the most chosen answer was incorrect. The least chosen answer was our correct answer. So this is one in which 8.10 say we need to spend a lot of time working with our students on, but really, if we can help our students see that a 90-degree counterclockwise is the same as that 270 degrees clockwise, same with this, that 270 degrees counterclockwise is the same as 90 degree clockwise, then we only need to memorize a few of these. What is a 90-degree counterclockwise, a 90-degree clockwise, and then how to tell the difference, and then they will be good to go when they see this in the future. Number 36, we are looking at slope in similar right triangles. This is 8.4a. And so we've got a line on a coordinate grid, and that includes the hypotenuse of a triangle. And then I've got a similar right triangle, UVW. So if vertex W is at 0, 2, all right, so 0, negative 2. All right, so the slopes of the hypotenuse of the two triangles are equal. So which order pair could be the coordinates of vertex V? Now, we've got a few different ways that we can look at this. Let me see. Here, let's zoom this in so we can see this a little bit better, just because those numbers are kind of small. So I'm going to open this back up, and let's take a look at our points here. Let me write them down for us, because there's, like I said, a few different ways that we can take a look at this. So I've got negative 6, 4. I've got 3, negative 4. I've got 0, 2. And I've got 6, 2. What I want to do is I want to plot all of those points, and I want to get them on our graph. Okay, so the point that they gave us is 0, -2. So right there on the line. Okay, so we're looking for which order pair could be the vertex, could be the coordinates of vertex V. Well, let's just plot each of these. -6, 4. So -6, 4 is right there. I'm looking at 3, -4. I'm looking at 0, 2. And then I'm also looking at 6, 2. Okay, now, just plotting these points here, we notice that only one of them is actually on the line. Now, the other vertex, we're looking at KLM, right? L and M are on that line. And I'm looking at UVW. Take a look at the order here. KLM, L and M are on the line. The order matters. I'm going to line up my U, my V, and my W. You notice that they gave me the W, and I'm looking for V. Well, if L and M are on the line, then V and W need to be on the line. So if this is vertex W, I'm looking for V. So that makes me think that could possibly be it right there, because that's the only other one on the line. How can I know for sure? Well, let's check our slope. Remember, our slope is our change in y over our change in x. So let's look at our rise over run on our original triangle. Okay, so it goes up 2, and then it goes over 1, 2, 3. All right, so I've got a 2/3 slope. Let's see if I keep these 2 points here. Will I keep that 1, 2, 3, 4? So let's see, 1, 2, 3, 4, 5, 6. Look at that. 4, 6. 2/3 equals 4/6. And that is going to work because that reduces down to 2/3. And it is on the line. And L and M are on the line. V and W both need to be on the line. So that's one way that we could use to solve this. And so let's go ahead and zoom back out. We've got our correct answer here of D. Now let's see how we did across the state. We had 24% of our students get that right. So obviously that is not very good. Our most chosen answer was actually 34%. 3, -4. Now 3, -4 lands right there. And the original point was 0, -2. So for some reason, they thought that was it right there. And really what that is that's reflecting L over the x-axis, right? And we're just kind of taking this point and we're kind of reflecting it over and thinking that's it, but that's not how that's going to work because the slope of a line is going to move it up a little bit. So we had 34% on that one. We had 24% over here, and then 18% on A. So quite a lot of guessing. Honestly, this is one in which we need to talk to our students about the order of these make a difference. And if we can place L and M on the line, that means that the V and W also need to be on the line. And since they're asking for those two, just plotting these 4 points is going to work for us. So this is the second hardest, tied for the second hardest item on the test. 24% is just a hair below even guessing. So that's one in which we need a little bit of work to help our students. For number 37, we are ordering numbers. This is 8.2D, and this is a multiple select. We need 2 correct answers here. We are looking for numbers that have a value greater than pi. Okay, so I'm going to go ahead and just put our equivalency for pi. It's equivalent to 3.14. And so we can just put that right there. And let's just use the calculator. And let's just get some equivalencies for these. 8 over 3 is 2.66. So that is not larger than pi. 6, 6. Repeating. 3.14. Now that's interesting. So remember, pi is about 3.14, but honestly, it keeps going. It's 3.1415, and then it goes on, which means this is actually slightly smaller than pi. But I bet you that messed up some of our students. Let's keep going. 23 divided by 22 is, yes, that's going to work because pi is also equivalent to about 22 over 7 is another equivalency for pi. Not exact, but equivalent. So 23 over 27 is definitely going to be larger. That's 3.28. So let's grab that one. Square root of 9, it's 3. So that's too small. So it's got to be this last one. And let's figure that out. So let's do the square root of 10. Yeah, 3.16 is larger than 3.14. So that's it right there. So those are our two answers, option 3 and option 5. As you can probably guess, we did fairly well on this. We had 73% of our students get full credit. We had 19% of our students get 1 point. So if you put those together, you're looking at about 82%. Only 7% of our students got nothing. So that's pretty close to just guessing statistical noise. This was the first easiest item on the test. So these problems with 8.2D, especially with the use of the calculator, was pretty simple for our students. For number 38, we are looking at one variable equations. This is 8.8c, and we simply have to find the value of x that makes the equation true. Now we've got two different options here. We are given four answer choices. So if we want to, we can use substitution and we can plug and play. And we can just plug in 7, -21, -1, and 3 into each of these x values in succession and find the one that creates a true equation. Or a quicker way would probably be to solve for the unknown, and that would work even if you didn't necessarily have four answer choices to choose from. So let's do that second option. Let's solve for the unknown, knowing that you could just plug these in if that's an option as well. So I want to combine like terms, and I'm noticing that on the left side of my equation, I've got two different x's. I've got a positive 2x and then a negative 4x. I also have an x on the right side. But first, let's combine these two. So I want to use the commutative property to rewrite my equation. And I'm just going to flip-flop where these are going. When I'm adding or even when I'm multiplying, right? I can change the order of these two. So now I can group these two together, right, with the associative property. 2x minus 4x. What is that going to be? Well, if I have a 2x, so think of our number line. If I've got 2x, right, and I need to take away 4x, well, that's 2 to get back to 0. Another 2 gets me to -2. That's my -4. So I'm going to have -2x plus 9. And we still have the x minus 12. Well, I want my x to be positive because you always want to end with a positive x. So let's add 2x, excuse me, to both sides. So my -2x and my positive 2x is going to just cancel out. I'm going to end up with 9 equals x plus 2x makes 3x. And so I've got my 3x on one side. I want to get my constants to the other side. So I've got a minus 12 on the right side. So if I add 12, that's going to cancel that, right? -12 plus 12 gets rid of it. So I need to have a plus 12 on the other side to balance it out. And that's going to end up being 21. 3x equals 21. Now I simply need to divide both sides by 3 to change that coefficient down to 1, which basically makes it disappear. X is 21 over 3, or x is 7. Now let's double check. So 2 times 7 plus 9 minus 4 times 7 equals 7 minus 12. Well, 7 minus 12 is -5, so the left side should equal -5. That's going to be 14 plus 9 minus 28. That's going to be 23 minus 28. And yes, that does equal -5. So that means 7 is correct, and that is our answer A. We did pretty well on that if we're looking at our state data. 59% of our students, just a hair below that threshold of what we're looking for of 60%. We had 16% of our students choose B. That's if they add x to the left side of the equation on accident. We had 15% of our students choose D, 3. That's if they add the 2x and the 4x rather than the 2x minus 4x. And then we had 9% some statistical noise with that -1. So overall, this was pretty easy. In fact, this was tied for our 13th easiest item on the test. So I just showed one of two possible ways to solve this. Like I said, you could also take each of the values, plug them in, and you would have gotten lucky because the first one, 7, you would have used would have gotten you correct, but it could be a lot of work if the correct answer had been D and you had to go through A, B, and C to figure it out. Next, for number 39, we are looking at trend lines. This is 8.5D, and what we have here is a catering company. We got a little scenario with that catering company. We're going to record the total number of cookies that are eaten at events. And I'm looking at my scatter plot here. I'm looking at 45. All right, so 45 happens to be, if I'm looking at my x value, right? Guests is my x value. So 40, 42, so there's 44. So it's going to be a hair off the actual grid there. So what we want to do here is we want to find some lines that we think are going to be, or some dots that we think are kind of representative of what we can use here. And what I'm noticing is kind of like that dot right there of the two that are on the 32y line, the 28 and the 30 x value. That 30 seems to kind of fit between those two. And then almost right in line seems to be that one right up there. And honestly, that's kind of standing on its own, so we're going to need to include that value at 3841. So let's use those two. And what I want to use, I want to use connect line. And even though, notice down here you've got this little peak and valley right there, that means they kind of cut off the chart, right? They're counting by twos, but they jump from 0 up to 20. So that means they cut it off, but they did it for both, so it's still proportional, which means we can still start at the origin. So what I'm going to do is I'm going to take this line and I just want to connect it. And I want to go through those two lines that I identified, those two dots that I identified, especially this one up here, since that's kind of standing on its own. I had to kind of make a choice between this one because this one ends up going through that, and that one right there looks to be kind of like an outlier, so I don't really want that one. All right, so now if I'm looking for 45, so 45 is going to be right around here. It's going to be a little bit past. So if I go up here, now I'm also, well, I'm also off the chart that way. So I have to guesstimate that. So this is going to be kind of a guesstimate unless I do something else. So I'm looking at 46. I'm looking at maybe a 48. And I'm thinking this is kind of looking at like a maybe 49. 49 or 50 is where this might be. So if I'm looking at my options, the only one that's really close is that 48. But I kind of overestimated. I thought it might be 49 or 50. So the other way that we can do this is once we identify, right, two of these. So what are my two values that I identified? 30, 32, and then my 38, 41. Well, I can find the slope of that, right? I can find the slope by subtracting the y values. 41 minus 32, 38 minus 30, right? My change in y over my change in x. So I've got 9 over 8. So that's my slope is 9/8. Almost 1. It's just a hair above 1. Now remember, my direct variation is y equals kx, right? You take your x value, multiply by the slope, boom, you get your y value. Well, now I have identified my k, or my m, and it can be both, as 9/8, and we say my value of x needs to be 45, so let's use a calculator. Let's multiply 9/8 times 45. Let's just see what that gets me. And I'm going to get 50.625. Okay, so I was right with that 49 or 50. And so it should be at around 50th, so y should equal 50. Now, let's look at our options. We don't have anything close to 50 except for this. And quite honestly, if we wanted to graph the others, everything else is going to be too low. So let's look at our other options. I'm going to put these in blue. Okay, so my 40 or my 48 is maybe right there. If I'm looking at it's a little bit low perhaps. But what are my other options? Well, I could do 44. Well, that's not going to work. Remember, it's a little bit off the graph, but look at how low that is. There's nowhere near that for the trend line, right? I've also got a 41, no, and then a 39, definite no. So even if I really think that it should be closer to a 49 or 50, 48 is by far the closest one, and we are approximating, which means we are going to select that, and that will be the correct answer of C. So when we approximate, we just need to get close, and in this case, the other answer choices are pretty obvious that they are not correct. So this one we did fairly well with, and we should feel pretty good about this. We had 62% of students do that. They correctly selected 48 with a trend line, so that is fantastic. And as we would expect, the next chosen item, D, 17% was the next highest item. 44 was the closest to 48. And then we had 11% here. We had 10% here. So close to statistical noise. This was pretty easy. In fact, this was our 10th easiest item on the test. So we did fairly well with that one. Now we are on the final item of the test, number 40, and we are looking at 8.4b. This is slope as unit rate, 8.4b. So a worker paints 4 cabinets in 8 hours. So I'm going to put 4 cabinets in 8 hours. I'm going to keep the units on there momentarily in case I need them. So which graph has a slope that best represents the number of cabinets the worker paints per hour? Okay. Now, when we are looking at this, notice we've got our 4 cabinets, 8 hours. We've got our cabinets as our Y value. We've got our time, H, as our X value. Okay, so that they did give it to us in the correct order for slope. Sometimes they'll give it to you as X first, Y second, and you've got to flip them. So always check the units first. But they give it to us as 4/8. So what is 4/8? That's 1/2 or 0.5. Now, if we know things about slope, we know it is going to be a positive slope, but it's going to be a shallow positive slope because the closer to 0 it is, the shallower it is, the closer to, 100, 200 it is, the steeper it's going to be. So it's not going to be A, right? Because we don't necessarily have a slope. That is just a horizontal line. This is just y equals 8, so it's not going to be A. Let's look see what else we have here. So we can eliminate C as well. That also has a horizontal line. So I've got 2 slopes that I can actually deal with. I've got a B and a D. So let's look at those two. Remember, they gave us 4 as the Y, 8 as the X. Well, let's just check that, right? 4 as the Y. 4 cabinets. Let's do that with B first, right? I've got 4 cabinets and 8 hours. Well, first off, that looks like it's going to be too steep of a slope. And secondly, it doesn't hit that one point. So that is, honestly, that's if you flip it. We're going to hit that 8 over 4 rather than 4 over 8. So that's a slope of 2 rather than a slope of 1. Look to see what we're going to get on D here, right? We have 4 cabinets, 8 hours. That's a x value of 8, y value of 4, and we hit it right there. And that is our slope of 1/2 because we go up 1, we go over 2. So we're ending on a fairly easy one. And our students did pretty well on this. So we, for the most part here, let's take a look. We got a 64% correct. So we should feel pretty good because for the most part, our students succeeded on this one. And let's just look to see what our other options were here. A, B, and C. As expected, the second most chosen was at least the other one with a positive slope. We didn't get many students to choose that horizontal line, so we had 24% choosing B, and unfortunately, what that was a slope of 2. They did the inverse. And then we had 5% choose A, and we had 7% choose C. So this was the 8th easiest. It was kind of a good item to end the test on, because it tended to be on the easier side for students.